Hello students, welcome to my class. Today I am going to discuss the lagging questions of my previous class, that is from 36 to 40. So let me first discuss 36. Here it is given charge Q1 is equal to plus 6 nanocoulomb on y-axis at y equal to plus 3 centimeter, and charge Q2 equal to minus 6 nanocoulomb is on y-axis at y equal to minus 3 centimeter. Calculate force on a test charge Q0 that is equal to 2 nanocoulomb is placed on x-axis at 4 centimeter. Then first let me draw the diagram that this is y-axis and this is x-axis. So here Q1 equal to what? This is the position of Q1. Q1 position is that is equal to 6 nanocoulomb plus 6 nanocoulomb, and it is plus 3 centimeter. Plus 3 means positive side of x-axis 3 centimeter plus 3 centimeter, and charge Q2 that is equal to minus 6. So this is my Q2 that is equal to minus 6 nanocoulomb. It is placed at minus 3 centimeters. So this distance is minus 3 centimeter. And another charge that is Q0 is placed on x-axis at positive x, means let this is positive x. This is the position of Q0 which is given 2 nanocoulomb, and this distance is 4 centimeter. So you can clearly see this is a dipole. These are equal and opposite charges separated by 6 centimeter apart. So here I can write the length is, total length is dipole length, that is 2L. 2L is equal to what? 3 plus 3 that is equal to 6 centimeter. Not this is 3 plus minus 3 that is equal to 0. They are been separated by 6 centimeter. So this is my 3 and this is 3 that is equal to 6 centimeter. 2L equal to 6 centimeter, and magnitude of those charges Q1 or Q2 whatever. Q1 magnitude both having the same magnitude. So this will be equal to 6 nano. Nano means 10 to the power minus 9 coulomb, and it is centimeter. Centimeter means this is 6 into 10 to the power minus 2 meter. Then this distance is R. R I can write R is equal to 4 centimeter. 4 means 4 into 10 to the power minus 2 meter. And Q0 will be equal to 2 NC. And then I have to find out what will be the force on Q0. I can say as this is a dipole. So this force, it will ultimately repel this because they both are having same charge. They both are having same nature charge, and this will attract this charge. Then I can say the resultant of these two forces will move in this direction, means negative y-axis. So I have to find out the option which are negative y-axis. There are two options, A and C. From A and C I have to find out which one is correct. Then how can I find out? Let me find out the force between first Q1 and Q0. First force between what? Q1 and Q0, that is equal to K magnitude of Q1, that is 6 into 10 to the power minus 9, and magnitude of Q0 that is equal to 2 into 10 to the power minus 9, and their distance of separation is, this is 3, this is 4, this will be 5. This is Pythagoras, they are Pythagoras triple. This is 3, this is 4, and this will be 5. 5 square that is equal to 25. So this is FQ1 Q0. Now let me find out FQ2 and Q0. FQ2 and Q0. This will be equal to K. Magnitude of QT is also same, that is 6 into 10 to the power minus 9 into magnitude of Q0, that is equal to 2 into 10 to the power minus 9 by distance, square of the distance. If this is 4 and this is 3, this will be of 5. This will be also 25. So I can see here the magnitude of the two forces are same. So the resultant force, this is F net. F net will be equal to what? As this is a right angle triangle, I have to find out here cos theta. What will be the value of cos theta? This is 5, this is 4. Then I have to find out the angle, this angle, theta. This will be also 4. And cos theta, I can write cos theta. Cos theta equal to what? Cos theta will be equal to cos theta will be equal to base by h. This is 3, this is 3, and this is 5. Cos theta is equal to what? 3 by 5. Cos theta will be what? 3 by 5. Then f net will be equal to, let this is, I am denoting it as f1 and denoting it as f2. f1 cos theta plus, sorry, I can write here only f because their magnitude is same. Magnitude of f q1 q0 and f q2 q0 are same. Instead of f q1 q0 and f q2 q0, I can write here only f. So this is, first one is f cos theta f cos theta, second one is also f cos theta. This will be equal to 2f cos theta. 2 in place of f I can write, in place of f I can write k into 6 into 2 into 10 to the power 99, that is minus 18 by 25. It is in centimeter. If I am converting into meter, this will be of 10 to the power minus 4 square. This is given here r square. R square means 5 into 10 to the power minus 2 square. 5 into 10 to the power minus 2, that will be 25 into 10 to the power minus 4. So this will be 25 into 10 to the power minus 4. This is the value of f, and value of cos theta is 3 by 5. 3 by 5. So if I am solving this, what can I get? Then this will be equal to 2, it is equal to 2 into k. In place of k I can write 9 into 10 to the power 9, that is 1 by 4 pi epsilon 0, and it will be 9 into 10 to the power 9, because 6 into 2, that is 12, 12 into 3, 36 by 25 into 5, that is 125 into 10 to the power minus 4, and again it is 10 to the power minus 18. So this is 36 into 72 by 125 into 9 into what? 10 to the power, this will be minus 9, and if you move to to the numerator, I can write here plus 4 minus 9 plus 4, that is minus 5. Minus 5. And by 125 into 10 to the power minus 5. I am using calculator because this multiplication will take time. This is 648 divided by 125, that is equal to 5.18. This is equal to what? 5.184. This is equal to 5.184 into what? 10 to the power minus 5. So the option will be what? Minus 51.8. J cap. And J cap, why J cap? Because I have shown in my previous slide that the force is going downward, that means a negative y-axis, so it is written here minus, and J cap is because that is the force is directed in y-axis, in negative y-axis. For negative, this minus is here, and for y-axis I can write the option will be J cap. And why that micro? Here it is 10 to the power minus 5, and if I am converting for this to my option, this is minus 51.8, minus 51.8, and J cap micro Newton. Micro will be for minus 6. Here I am writing here 51.8. 51 means I am developing here again a minus 1. This will be minus 6. Minus 6 will be for this micro. So the correct option will be what? Option number A. Then the next question is the electric intensity. The electric intensity will be electric field intensity. Electric field intensity outside a charged sphere of radius r is at a distance. So let me draw the graph first. So the graph for a sphere of radius r. This will be inside electric field inside a sphere. It is directly proportional to its radius, and on the sphere it will be constant. And if we will move away from the sphere, the electric field intensity will inversely proportional to r square. This is the graph. So here the question is about outside a charged sphere. That means we are moving away from the sphere. So what will be the option? The correct answer is electric field outside the sphere. That will be E is equal to E is equal to K Q by R out square. So instead of Q, I can write what I can write? The surface charge density sigma, how much charge retained on a surface. How much charge is retained on a surface. That is sigma is equal to Q by A. S because that is a sphere, so I can write Q by A is equal to 4 pi radius square. 4 pi radius square, the surface area of a sphere. Then Q will be equal to 4 pi r square of sigma. So instead of K, I can write here 4 pi epsilon 0, and in place of Q, I can write 4 pi r square of 6 by r outside square. So 4 pi will cancel out each other, and this will be equal to, this is sigma. This will be equal to E is equal to what? Sigma r square by r out square of epsilon naught. So the option will be sigma r square by epsilon 0 r out square. The option A will be our correct answer. Option A will be our correct answer. Then the next question is, an uniform electric field E exists along positive x-axis. The work done in moving a charge plus 5 coulomb through a distance of 2 meters along the direction making an angle 60 degree with the x-axis is 10 joule. The magnitude of electric field. It is a very easy question. Here it is given, an uniform electric field E exists along positive x-axis. My electric field is going in positive x-axis. This is the direction of my electric field. Work done in moving a charge 0.5 coulomb through a distance of 2 meters along the direction making an angle 60 degree with the x-axis. This is my x-axis, this is y-axis, this is y, and this is x-axis. Electric field is going in positive x direction, and another charge is making an angle 60 degree with x-axis. A charge is moving like this. This is my charge, is making an angle of 60 degree to the x-axis. What is the magnitude of charge? Magnitude of charge is 0.5 coulomb. So work done is 10 joule. We know work done W is equal to dot product between force vector and displacement vector. Force vector and displacement vector. That will be equal to, that is equal to F equal to EQ. We know that Coulombic force F is equal to what? Electric field times of charge. That is E and Q, and for displacement I can write here, this is displacement is S and cos how much? 60 degree. Then W is given here what? 10 joule. It is 10 joule. That is equal to electric field. Electric field will be electric field. Where is my electric field? Electric field is the question. E and Q charge. What is the magnitude of charge? It is 0.5 coulomb. 0.5 coulomb. And what is my displacement? This is 2 meter. And what is the value of cos 60 degree? Cos 60 degree, value of cos 60 is half. These two will cancel out each other, and that electric field E is equal to 100 by 5. That is equal to 20 volt by meter. Volt by meter and Newton by coulomb. These are two units of electric field. So this will be also equal to 20 Newton by coulomb. The magnitude of electric field will be what? 20 volt by meter or 20 Newton by coulomb. Then next question. That is, these questions are very simple type questions, easy type questions, and these are generally asked in CHSE exam and board exam or 12th board exam. Even they are asked in NEET JEE also. 64, next question is 64 small drops of mercury, each of radius r and charge q, coalesce to form a big drop. The ratio of the surface density of charge of each small drop with that of the big drop each. What happened? 64 drops, 64 mercury drops. These are how many times? 64 mercury drops are combined to form a large drop. They are having, each are having radius r. They are having radius r and charge what? Charge is q. Let this is radius r and charge capital Q. So S, because the 64 charges combine to form the larger drop, so total charge, that will be 64Q, will be equal to that of capital Q. And let me find out the radius ratio. Means 64 small drops are combined to form the large drop, hence the volume will be same. 64 of volume of small spheres will be equal to volume of the large sphere. The volume formula for a sphere is 4/3 pi r cube. This will be equal to 4/3 pi capital R cube. These will cancel out each other, and instead of r I can write this is cube root of 64. 4 smaller. And surface charge density, ratio of surface density for smaller sphere. Smaller will be equal to sigma is equal to q by a. This q by a, in place of a I can write 4 pi small r square. And for larger drop, this will be q by 4 pi r square. So ratio of surface charge density, surface density of this each small drop to that of big drop, means sigma small drop by sigma big drop or large drop, that will be equal to sigma s. In place of sigma s I can write q by r square into, in place of sigma large I can write r square by capital Q. This is q by r square into r. In place of r, that is 4r. So I can write here 16 small r square by capital Q. In place of capital Q I can write 64 small q. I am cancelling out this. This will be 1 by 4. So the option will be 1 by 4. This option number D will be my correct answer. And for today the last question is 2 point charges 100 microcoulomb and 5 microcoulomb are placed at a point A and B respectively, with AB is equal to 40 centimeter. The work done by external force in displacing the charge 5 microcoulomb from B to C, where BC is equal to 30 centimeter, angle ABC is equal to 100 microcoulomb and 5 microcoulomb are placed at A and B respectively. This is position of A. This is position of A and this is position of B. Here it is 100 microcoulomb and 5 microcoulomb. B is at 5 microcoulomb. Respectively, AB is equal to what? 40 centimeter. This is 40 centimeter. The work done by external force displacing the charge 5 microcoulomb from B to C. This charge is being moved from B to C. Let this point is C. The charge of C is 5 microcoulomb. B to C. BC is equal to 30 centimeter. This BC, that is equal to what? 30 centimeter. And ABC angle is 90 degree. ABC angle, this is 90 degree. As because this is 90 degree, I can draw a right angle triangle. So this is my P, this is my B. The H will be of 50 centimeter by Pythagoras triple. Then I have to find out the work done, W. W is equal to, we know that W is equal to VQ. W is equal to what? Q and potential difference. potential difference W equal to BQ means potential difference between potential difference between B and potential difference between C. Potential difference between B and potential difference between C. Q is what? 5 microcoulomb. So how can I find out potential difference? Let me find out potential at B point is equal to K charge. Charge is what? 100 microcoulomb. Micro means 10 to the power minus 6 by distance, that is 40 centimeter. 40 centimeter is 40 into 10 to the power minus 2. We know their potential, general formula for potential is V equal to KQ by distance. This is my general formula. V is equal to KQ by R. K charge is what? 100 microcoulomb and distance is what? 40 centimeter. So this will be as a 0. I am considering out 0 and 0. This is 10k by 4. 10k by 4 of 10 to the power minus 4. This is 5 by 2 k of 10 to the power minus 4 volt. This is my potential at point B. Let me find out potential at point C, that will be equal to K of charge is 100 micro means 10 to the power minus 6 KQ by distance. Distance is 50 centimeter. 50 centimeter is 50 into 10 to the power minus 2. So this will be equal to 0. This will be 2k into 10 to the power minus 4 volt. This is 2.5 k 10 to the power minus 4 volt. This is 2k 10 to the power minus 4 volt. Potential difference will be, this will be Q of 2.5. 5 by 2, that is equal to 2.5. 2.5 k of 10 to the power minus 4 minus 2k of 10 to the power minus 4. I am taking here 10 to the power minus 4 as common. So let me solve this. Then W is equal to Q. In place of Q, I can write 5 microcoulomb. 5 micro means 10 to the power minus 6, and 2.5 minus 2, that is equal to 0.5 of K. In place of K, I can write 9 into 10 to the power 9, and this is 10 to the power minus 4. So W is equal to, this will be 4.5 of 5 into 10 to the power minus 1, 22.5 into 10 to the power minus 1, that is equal to, this will be equal to 2.25. This is equal to 2.25 into 2.525 joule. So which will be my correct answer? 2.25 minus 9.4, 9 by 4 of joule. Why there is negative sign? Negative sign is because this is shorter distance 40 centimeter, this is longer distance 50 centimeter. If I am taking this charge from this point to this, ultimately the potential will decrease. The potential will decrease. Why potential decrease? We know the formula. V is equal to what? KQ by R, and V is inversely proportional to R. V is inversely proportional to R means if we are increasing the distance, the potential will ultimately decrease. This is 40 centimeter. If potential is here VV, and potential at C will be potential that will be VC, and it will decrease potential. So decreasing potential means negative signs. The option will be minus 9.4. If this is minus 9 by 4, that will be equal to 2.25. So our and D is equal to minus 9.4. The negative sign indicates that potential is decreasing. So these are all about the discussion of DHSE for the month of September, which I am discussing in the month of October. So I hope all of you have enjoyed this video, and thank you so much.